Welcome to the Crazy Hat Chemist. So here we go. Today is the Lewis dot structures number 2. So before you start this video, I want to make sure that you review the video on Lewis dot structure rules and exceptions to Lewis dot structures. Pull out a piece of paper, a pencil, and let's get started. So here we go. Bam! Drawing Lewis dot structure rules. Drawing Lewis dot structures number 2. So we're going to draw the Lewis dot structure for boron trifluoride. So hopefully you review the lecture on nomenclature. Boron trifluoride is 2 nonmetals. It has a prefix there of tri, that means 3. Okay, so 2 nonmetals, prefix naming, boron, B, fluoride, F. How many fluorides? Tri is for 3. So here's my correct formula for boron trifluoride. Now I'm going to look at my periodic table here behind me and figure out what group is boron in. Okay, and it is group 3. Okay, and so therefore there are 3 valence electrons for boron. Okay, how many borons do you see in here? 1, so I'm going to multiply that by 3 by 1, and then there we go. Now I'm going to look at fluorine on the periodic table, and what group is that in? That will tell me the number of valence electrons for fluorine, of which is 7. How many fluorines do I have over here? And that is subscript there of a 3. So I'm going to multiply the 7 and the 3. I'm going to add these 2 numbers up, and then I get 24 total electrons. Okay, now what I did on the previous one is I divided all of them by 2. So that will give me this number right here, and that is 12 pairs of electrons. Okay, so I've got 12 pairs of electrons, not 12 electrons, because I got 24 electrons, but I have 12 pair. It works much better if you work in pairs. It's much faster and easier to do Lewis dot structures. So the first thing that we need to do is we need to draw a plus sign on our piece of paper. So go ahead and do that. Then figure out which element is the least electronegative. The least electronegative is the one that is furthest from fluorine. And of course, it can't be fluorine. So therefore, it's going to be the boron. So the boron is the least electronegative, and that is going to be in the center. Now you have a plus sign, okay? And now you're going to draw the other 3 elements. We only have 3 other elements that go around the boron in a plus-like pattern here. We don't have one on the top. We could have had one on the top. Could have not had one on the side, but we do need 3 borons. Then the other thing that we need to do is we need to take our bond blender. Hopefully remember that from before on the rules for drawing Lewis dot structures. You're going to take your bond blender and you're going to take 12 pairs of electrons. Those are going to go in there that we added up. Now you're going to take your bond blender, shake it all about, and now we're going to disperse those electrons as is appropriate. So the first rule is to place pairs of electrons between the central element and the outside elements. So the central element is boron. The outside elements are the fluorine. So there's 3 of those. So I'm going to use 3 of the pairs of electrons from my bond blender. And I'm going to take that, and then this is what I got right here. I've used 3 of those pairs of electrons that are in my bond blender. Okay? Now, the next rule is to place lone pairs of electrons on the outside elements as lone pairs, non-bonding pairs of electrons. Bam! There's that right there. Okay? And once I did that, I don't have any more electrons from my bond blender. So I'm done with using my bond blender. Okay? Now I need to verify the rules. So, verifying the octet rule for fluorine. Fluorine is period 2. It follows the octet rule. It must have 8 electrons around it, and I see 8 dots around each fluorine. Okay, then I'm going to circle the boron. Now, the boron is deficient. That is less than an octet. However, if you looked at the video on exceptions to the Lewis dot structure rules, then you should understand that boron and beryllium can be electron deficient, and that is perfectly fine. So now that we have verified all our rules, and they do apply, then we can redraw our structure. Lone pairs are still dots that are non-bonding pairs. Okay? And then bonding pairs of electrons are going to be drawn as lines. So here we go as lines. So this is the Lewis dot structure, the correct Lewis dot structure for boron trifluoride. Hopefully that worked out well for you. Give that one a try again. I'm not sure if this is a crazy hat or just crazy hair. All right. Give me a thumbs up if you like that video. Please subscribe to my channel on YouTube. and have a good day. Look forward to the next video. Bye now.